live event. I'm Patrick Davis. I'm the Chief Operating Officer of Safe-Decon, and I'm your host for today. So thank you for taking part in today's discussion or being a part of the event because, all right, I'm sorry. Let me get this person admitted here. Trying to do, I want to make sure everybody gets in. Even while I'm talking here, I want to make sure everybody gets in. Okay. All right, guys. All right. The bottom line, ladies and gentlemen, is when decontamination is based on guesswork, all right, the stakes aren't just high. It could be potentially life or death. All right. The truth is current decontamination processes are not consistently sterilizing material. They're only effective about half the time. All right. And when half of your cycles are failing, and we've got evidence in the paperwork to show you, but when half of your processing and your cycles are failing, that's not a process, that's a gamble. All right. So, so most of the processes are built on the wrong foundation. Most of the people in the industry, we've done this a couple of years traveling. I have personally, most of the people in the industry just don't understand how autoclaves work. So today we're going to dive into autoclave fundamentals, where the processes fail, and how to replace guesswork with validation. All right, we want to keep you guys safe. So the person that's going to be leading the discussion today is Mr. Bob Dudley. All right, he is our CEO, founder, inventor, lead technician. He's been in the industry for nearly 2 decades. He's got hands-on experience servicing, installing, validating, sterilization, decontamination, hospitals, research institutions, and all kinds of high contaminant laboratories nationwide. All right. He's worked on, he's got knowledge in Steris and Getting, Consolidated, and Tuttenhauer autoclaves. So he's been, he's known in the industry for resolving complex problems. And, due to his exposures, this was a problem that he decided he was going to solve. And, finding out what I found out, I'm thankful that he has. So without further ado, last thing, as we're talking, guys, as he's going through, Bob is going through his presentation, if you guys got questions, throw them in there. We may address them, but we want you to, as they come to you, throw them in the chat there. So when we get to the Q&A, we'll have the questions and we'll be able to dive into some good Q&A. So without further ado, our founder and the leading authority, Mr. Bob Dudley.
Thank you, Pat. I want to thank everybody for being here. Just to let you know, I've been doing it for 2 decades, and Pat is right. I did have a situation years ago when I first got into this, and it really kind of made it personal. But some of the people know me, but I have been exposed on 3 different occasions, quarantined twice, and monitored for the 3rd one. The reason that this is kind of a thing for me is one of the labs that I worked with, one of the exposures that I had was an uncurable TB that was over in Asia. And then I had to go home and explain to my wife that I may have killed us both. But as you can see, ended up not with the TB, but I ended up with an upper respiratory virus that was going around that they were also working on. And I suffered for about 4 or 5 months with that. So it is something I do take very, very personal, and especially in this. And I have been into a lot of high level, high containment. It was one of my specialties. So I have a lot of information here today. You guys are about to become very adept at the sterilizer, the autoclave, decontamination. So we're going to go ahead and get started. Like I said, it is a ton of information. Pat, just want to make sure that my screen is up here. I'm going to forget who I am here. I don't do well talking about myself, so I'm going to dig right into this. The known fact is, even though we have protocols, we have SOPs, safety officers, we know that things don't always go right, and especially when handling biohazardous materials, getting them around throughout the facilities and stuff like that. Accidents do happen, and we do have we do have a lot of accidental exposures and stuff like that. And I am the absolute living proof of that, as you just found out. On average, here in the U.S., there's 20 to 30 that are lab leaks that are reported every year. A lot of them, they still don't have 100% sure how they got out. After you learn what you've learned today, you may find out why some of them are leaking. Some of the challenges that we faced, and everybody's trying to do the same thing. We want achievable, predictable, validated decontamination results. We want to be able to verify it. But it presents some very, very serious challenges. Steam penetration, inconsistent. You have plastic bags, and plastic is, the plastic bags are an insulator to heat. They also will stop steam from coming in. And today you're going to learn about steam. Now, a lot of people have the misconception that steam is what actually gets you to kill. Steam is not what kills. You will learn that today. It's actually the heat. And I will explain steam function, and why steam is used in decontamination and sterilization. Very, very important that you differentiate between the two. Liquids absorbed, a lot of the labs, you have liquids, you have media, you have a lot of different things. Liquids absorb differently than anything that's dry. So again, that's going to have an effect on your sterilization and decontamination of all your products. And again, we're going to get into we're going to break everything down, really break things down so that you get a clear and absolute understanding. This is one of my key points here, which is operators often do not have clear SOPs. And for 2 decades, I've been going, again, into a lot of facilities all over the country. And the one thing that I've learned through this, guys, is that there's no SOPs on the walls. There's no true understanding of how things should be stacked in an autoclave. You have SOPs and everything for everything that's in there. I find that especially when you get into the autoclaves, that there is this is one of the big major problems. And to be honest with you, this here, the operators and stuff, this is what's gotten me exposed on multiple occasions. Confirmation of sterilization is often assumed and not verified. What I've learned, especially in the last 4 or 5 months, is that people regard the autoclave as this wonderful black box. You go in, you throw it in, you hit a button, everything comes out on the other side. You really don't have to worry about it. The confirmation of sterilization is generally either done with a chemical strip, which we will go over, the chemical heat strip, or the biological indicator. Now, the biological indicators, and a lot of this, and again, this comes from absolute experience, is that they're not placed in a proper response. And the reason is who wants to go digging around in biohazardous waste to retrieve their biological indicator? And everybody fusses about it. It's gross, especially when you're dealing with animal waste, animal bedding, and stuff like that. So the autoclave, as you can see, there's one behind me here. The autoclave is really a very simple concept, folks. It's just a very fancy pressure cooker. They become more complicated over the years, as you very well know. You have to be an electronic genius to work on them. They break down a lot. It's as I call them, the dragons that can't be slayed. They're inevitably breaking down, but then again, you have water, heat, steam, electronics. It generally doesn't end well with these, and they're, especially now that they're problematic. And I'm old enough to remember the old autoclaves where you had 3 knobs. You flipped a switch on, you turn the knob until you reach 15 psi. you turned another knob on and it filled the autoclave with steam. You had an egg timer. So yes, I'm definitely showing my age with these, but I do remember the old autoclaves, and they always just worked real well. Now you've got load probes and everything else that's in it. But that's what it does. And what does an autoclave do? It provides steam and heat to kill and to break down proteins and acids, and that's how it's how we pretty much get the kill. I'm going to go through here the physics of gas and mist. And one of the questions that I ask people when I'm out in the field is, do you know why we use steam? Steam is a gas that you have. And as anybody knows, when they're vapping the room, when you're decontaminating a room, they will use a gas of some sort, and whether it's hydrogen peroxide or something else. And what we know about gas is that it permeates. It's like air. If there's a pinhole, it will penetrate it. It gets under things, around things. It hits every surface, and it goes under and over and through things. That's why gas is very, very, very important. And this is one of the reasons why steam is so critical. Steam is actually a gas. And let me explain to you the difference between the gas and the actual vapor that you see. Now, what a lot of people do is, if you put a pot of water on on the stove and you bring it to a hard boil, everybody goes, "Well, Bob, I can see steam." That's true. You can actually see it, but then what that's turned into is your aerosol mist at that point. I guess I'm trying to break this down so you understand it. If you look down in the pot and you looked at the actual boiling part, you'll see that it's clear. And that's what gas is. That is what is going on inside of your autoclave. It's not steam that you can see. When you start being able to see the steam, now it becomes a problem. And those in healthcare kind of understand this. When you start getting a wet mist, then they get what they call wet packs within their autoclave. So as long as it's in gaseous state, it tends to permeate things really, really good. When it turns into a mist, you can look at it very similarly to the dew in the air in the morning. If you look, it's all over your car, it's on the top, but if you look underneath things, there's no mist underneath. That mist or the water droplets will get on things, but the coverage is actually not as good. And when you get to the mist part, especially in autoclaving and decontamination sterilization, when you start getting that mist or you start seeing that steam in the autoclave, you will start you're going to start getting the insulation and blocking factor of the steam. And we'll get into this when I start getting into steam saturation. But I just want you to know that gas is steam gas. If you were to take and a good way to test your autoclave to see whether or not you're running true gas or you're having mist problems or a problem with your autoclave is you can take a paper towel and you can put it in your autoclave, run a cycle. When you open that door and pull that paper towel out, it should be dry. That's if it's running correctly. If it's damp or wet, then you're having an issue with your autoclave. But that's just a fun fact. And so with that and the difference between a gaseous state and mist, I want to get into proper steam saturation. And this is something that most people don't know. And it's what you don't know is what gets you in trouble. This is why I wanted to bring up the steam saturation, because it plays an incredibly critical role in decontamination sterilization. If your autoclave is working correctly, you will have a steam saturation or the humidity in that steam of between 3 and 7%. Let me explain the difference. When you're trying to get steam, and this is one of the reasons that steam is so important. I'm going to go to the right side. Steam is nothing more than the hammer to the heat nail. And the reason that steam is used is the purpose of the steam is it makes the heat more effective and more efficient. If you were not using steam, and again, this is why you use the autoclaves, your decontamination process would go on literally for 5, 6, 7 hours. By being able to use a steam autoclave, you're actually able to reduce and your times considerably, as long as that steam and heat is able to come in contact and actually permeate what you're doing. Steam is the hammer to the heat the nails, and that's about as simple as I can make that. But steam is very, very critical. But the problem with steam is if it gets too dry and it gets less than 3%, it gets very arid, and then you do not get the penetration. When you get more than 7% saturation or humidity, then you start getting even more droplets, and then you start insulating whatever you're trying to get it into, or it will start settling on a mist, and then the heat can't, it's actually a block for it. So the steam saturation or the humidity of it is very, very critical. The best way I can explain the insulating effects is, I don't know how many of you been to Arizona and how many of you been to Florida. I'm originally from Florida. You go to Florida, very, very hot. Arizona in the summertime, very, very hot. The difference in the temperature is that you go to Florida where there's high humidity in the summer, it generally runs 90, 95%. It's not even raining. The temperature doesn't usually get above 92, 93, 95 degrees, even in the summertime. And yet they have a lower longitude. They're more in the tropical area. Where you go out in the desert of Arizona and it's arid, they get temperatures of 120, 30, even 140 degrees. And so the reason is it gets hotter is that there's not as much humidity to block that heat or to insulate that heat. So there has to be this critical balance when you're doing the steam saturation. And with life science, whenever you're trying to do liquids, this really becomes a problem. But the autoclave is designed to overcome this. And then we're going to get into that here in just a second. So now that you understand the steam saturation and the critical nature of it, I want to get into the effects of pressures in liquids. But knowing this, there is I want to bring this up because I've been trying to get with the NIH to reverse I guess it's not an SOP, but it's a recommendation that when you're autoclaving waste, that you add liquids to the autoclave bag to enhance steam. And what I'm going to show you today, that is a wise tale, a faux pas, and it's actually a very dangerous practice to do. And thermodynamics and the laws of physics are really it's against you. And again, I'm going to show you the testing results, and we're going to go through these thermodynamics and the physics of it all. So now that we understand steam saturation and effects of liquids, before we get into going into the cycles themselves and breaking them down, I want you guys to understand here a little bit about what happens. Now, the chart here that you see, this is a steam pressure chart where you have the difference between water and steam. Anything below this line is steam, anything above it. Now, what I want you to know is here, this is atmospheric at sea level. At sea level, water boils at 212 degrees or 100 degrees Celsius. That's in Florida. If you live in Denver, Colorado, all of that changes. This will drop down to, I believe, 92 or 186 degrees is your boiling point. So atmosphere does make a difference. And again, that's pressure pressure between water and steam. But for the sake of it, we're going to go with, atmospheric being here, 212, 100. Now, what I want you to know is everybody runs this number right here. And you're running at 15 PSI, and at 15 PSI equals 121 Celsius. And that's where generally everybody runs this thing. Now, if you have any liquids in your bag, your boiling point now becomes, I rounded it up, but it's actually 122.6. So at 122.6, you're not boiling anything. That water is just literally just sitting there. And as most of you know, when you run in a liquid cycle, boiling is bad. This is where you boil out. So you go, okay, Bob, we're trying to decontaminate. We really want to produce more steam. So we'll just crank up the autoclave. The autoclave is capable of going up to 32 PSI, which equates to 134 C or 274 Fahrenheit. So let's look what happens here. All right, so we're at 134. Your boiling point is now 135.8 or roughly 136 degrees Celsius. So as your pressure increases, your boiling point changes. And this is critical, especially when you're trying to, like I said, and some people add liquids to their waste in hopes to produce steam to get it to sterilize. Now, as you can tell, if you do get the steam, this is the temperature of your steam. This is the temperature of your water. So let's look at the reverse of this. And when you start pulling a vacuum on the other side, this is where the drastic change takes place. And I really want you to pay attention to this part, these two charts more than anything, because this is very, very critical when understanding your cycles. Okay. So here we are at 212 right here, 100 C. And then you start pulling a vacuum, and you can see here that the vacuum, this is your steam and this is your water. So most autoclaves will pull between 25 and 29. This is a good operating range for your autoclave. So now you're pulling a vacuum. So, for those that run pre-vac or dry cycles on your autoclave, look what happens to your water. At 25 inches, you're running 54 C. That equates to 129 degrees Fahrenheit. That is pretty much pretty close to where you set your hot water heater for hot water. And of course it starts getting way down here, and you can see how the curve does. Now at 30 inches, that's almost the vacuum of space right there. So you get your autoclave, and your autoclave is really good. And now you're running to 29 inches. Your boiling point is 21 C, or essentially that equates to 69 degrees. That's a beautiful spring day right there. Beautiful spring fall day, 69 degrees. And these two charts play a critical role in what happens during your cycles. Now, so let's go and have a discussion about what happens. Now, I put this chart up here because it had, pretty much every cycle. We're going to ignore the air over pressure. These cycles generally run in bulk sterilizers. They're used for a specific reason. The air over, they use a purified air to inject. Gravity with post vacuum, I don't worry about that because most of you guys are not using that so much anyways. I'm going to talk about the three major ones: the gravity, the liquid, and the pre-vac. Here you have what they call the purge on the cycle. Now, when you close the door, you put everything in. Most of you guys are operating, even the hospitals are at 68 degrees. The stuff is pretty chilled up. So what they do is they run this purge section in here, and it runs between 1 to 3 minutes. What that purge is doing is it's taking away every air pocket, literally everything that's in that autoclave. And of course, the door was open, and if you get an air pocket, it'll just condense and it will not heat up even under pressure. So the whole idea of the purge is to create turmoil within the chamber, and it also starts preheating whatever you have inside that you're trying to get warmed up. So it's trying to pull as much of the cooling. So when it goes through the purge, it's preheating the chamber, the drain. It just preheats the pipes. It preheats every part of the cold area of that chamber, and then it'll level off, and then you get your heat up. Now, if you look at the gravity in the liquid, they ramp up kind of slowly, and they have to do this for a reason, as opposed to over here at prevac where it's straight up and down. They do this for a reason. When you look at when you understand how the effects of steam, mist, and what goes on in this autoclave, and I'll detail that in the tests and explain why failures happen. But here it has to go up kind of slowly because you're not getting the steam penetration to the middle. And it's the same thing with liquids. Liquids here, they have to ramp up kind of slowly because the liquids have this insulating factor to them. So it, depending on, if you're doing 100 milliliters or you're doing 5 liters, it takes a while to heat up. So with the gravity in the liquid, what happens is it's going to pump in 2 or 3 psi right here, and then it's going to start heating up, and then it stops for a second. And if you ever listen to the autoclave, you'll hear the steam go in, and then you'll hear it click stop. And what's happening, especially with the newer autoclaves, is going through a little check here. It's going to come up and it's going to pump a little bit in, and the autoclave should check to see whether or not we're maintaining this heat. It's going to measure the amount of drop. So it may sit here after 2 or 3, and it's going to pump it in, and it's going to go, okay, or did we achieve the pressure? Is the temperature staying there? Is there too much drop? Now we're going to pump in another 2 or 3 more, and another 2 or 3 more, until it gets to the point. So if your sterilization, which is this line, is 121 or 15 psi, it's going to get to the very last check before it gets to sterilization right here and right here. And what it does is the computer makes one final check before it pushes over to sterilization. And it says, okay, let's look at everything in here. It wants to know the chamber pressure, the chamber temperature. If you're using a load probe, it's going to look at your load probe. It's going to look at the drain temperature to make sure, because the drain is the coolest spot. So it has to make sure that that temperature is up enough to kill. And then it's going to look at the pressures to make sure that the pressure equals temperature. 15 psi should equate to 121. So it has to make sure that everything's in place. And then it's going to do a last drop rate check before it gets to sterilization. And what I mean by drop rate is it's going to, the autoclave is going to go, we have an acceptable level to where when we get to 13 psi or 118 Celsius, what's going to end up happening is the how much drop in temperature is going to happen before we kick over to sterilization. If the drop rate is at, and some of them are preset for 1.5, 2 degrees over 30 seconds or potentially a minute. If we do achieve that, then you get the final push, and then it'll bring it up to sterilization. Now, once it gets to sterilization on these two, it's going to go back and recheck everything. And they do this just to make sure that the autoclave is working correctly. And this is generally where you're going to get a lot of your failures for those that just love their autoclave. Generally, what happens is it's going to make its final check, and then it's going to look for drop rate, pressure, temperatures, jacket, chamber, and it goes through a lot of checks. Now, where a lot of people get the failures and the frustration at this point, especially when you're doing liquids or a gravity cycle, is if you overload your autoclave in any way, it's harder for it to get deeper, and then the coolness of the air is going to come out and sink, and it's going to hit the probes. The minute it does that, especially in the drain, if because cool air sinks and the drain is the coolest, this is where you're going to get your failure. And a lot of places I go in and they fight us like, Bob, I get a heat temperature failure or a pressure failure, and then you open it up, let's see how you're loading it, and they have it stacked to the gills because it's Friday and the technician is 19, 20 years old, and they don't want to sit there all night, so they overload the autoclave, and then they end up getting a failure, and then they end up having to restart the whole thing over again. But if it's successful, you're going to run the amount of time that you're going to run, and then the ramp down. Now, the difference between the gravity and the liquid is the ramp down. And going back to this chart here, where you have pressure, where you have the pressure and the temperature of it and the boiling point. So if you're here at 121 and your boiling point is here, and then you suddenly drop here, but that temperature remains the same, what you've just created is a volcano. Now, the gravity cycle is exactly what it is. When you're finished with that sterilization part of this, what generally happens is it says, okay, sterilization complete, everything is good, and it's going to shut off the steam, and then it's going to open your drain valve, and then there's an air inlet, filtered air inlet valve, and it's going to ramp down. So if you have any liquids and your boiling point is for your liquids is 123, and then within 45 seconds it's going to go down to 14 inches, you've just created a volcano, a Mount Kilauea type of thing, where that water is all gone. So what they do here on the liquid cycle is they have what they call a ramp down. So the ramp down here is just gravity, straight down, open it up, let it rip. On the liquid, when it cuts off, it just stops. Nothing happens. It just goes into, you'll see that it goes into exhaust mode. Now, on the liquid cycle, and the reason I'm emphasizing this is because this is where a lot of frustration happens. People lose, sectional loss is 10% of your liquids. You're running your media, your liquids, and you look in there and half of it's gone. You're running a liquid cycle. You don't understand it. You call your technician. Let me explain what happens. So after the sterilization time is completed, you've run a 45-minute sterilization. Everything shuts off. No steam goes into the jacket, chamber. Everything just sits still for approximately a minute to a minute and a half. And what it's doing is it's resting, and it's trying to take away some of that heat that's in there. What generally happens on this ramp down is you should have a slow, what they call a slow bleed valve. It opens up and it just creeps it down. Now, the goal is to lose 1/2 psi per for every 2 to 3 minutes. And what it's doing is it's taking the heat out of the jacket and the chamber at the same time. So that allows the liquids to cool off for 2 or 3 minutes. Then it takes the pressure off of it. Then it just keeps going down, down, down. That's why your liquid cycles take such a long time. You're bleeding the pressure and the temperature down, and it should take approximately 50 minutes to an hour. If you're losing, and I'm just going to give you this advice, if you are losing more than 10% of your water on your liquids and your media is blowing up and you're getting this mess in your autoclave, then it's either one or two things. Either this ramp down timer is set too low, and you need to increase it. And some people will do them at 1.5 minutes. I tell everybody between 2 and 3, and then let that ramp down. If that is correct, then you have a steam trap in your chamber issue. And the steam trap should remain shut, it only cracks when there's liquids that build up and it has to get rid of the liquids. But if it's not seating correctly, that bleed down will go down and you will lose it. So just for FYI, if everything is right with the computer and you're still losing more than 10%, that chamber steam trap is gone bad on you. Now, I want to get over here. Now, this one is the champ right here. This is your pre-vac cycle. As you can see, it is extraordinarily different than these two. I'm kind of amazed when I go into a lot of these research institutions, and I see that most of them do not have pre-vac cycles. A pre-vac is called preconditioning sterilization cycle. So preconditioning is what is happening here. So let's talk about the pre-vac cycle. I love this thing, and I love it especially for waste. It is the champ, and I'll explain why. Here you have the same. So you have your purge, you got the preheating, and then you're going to have your warm up. But look what happens. You're pushing steam in. Now, what happens generally with steam, and this is why you're going to get a lot of failures with the gravity and the liquid that you're not going to get necessarily with the pre-vac, is you're going to push in steam pressure. As a rule, it'll push in about 9 to 10 psi. But what generally happens is when you're trying to get penetration on something, and I'll show you here on my test packs and explain a little bit better, but when you push that in and you start driving that steam into hard to get places, steam has a tendency to turn into water. So with this, you're pushing it in, the steam has to push in, and as it gets into the tighter, cooler places, it's gonna turn into that mist, and then it's going to block it. Liquids are an insulator to heat. So what they did is they created this so that when you get that push in, now you're at 10 psi, and it's really hammering. And what I like to say is this uses a tack hammer. This is a jackhammer. So as you push that steam in, it's driving it in. And as it gets to a certain point, it turns the certain amount of gas turns to liquid. And this is also critical. I want to bring this up because the more liquid or the more humidity, the more liquid it generates and the more it's going to block that heat from going in. So if you have more than 7%, that's that much more humidity, and it's going to create that much more rain within it that it has to expel and try to overcome. That's why if your autoclave isn't working right, heat on especially on the gravity, if you're using this for your waste cycle, it takes a lot longer to overcome that. Where here, this is very violent here. So as you push it in, it's going to create a barrier. But what happens? You're going to pull that vacuum. So now, you've pushed it into 10 psi. You're right there at 115 degrees. You've got that block. You pull a 25-inch vacuum, and now that temperature of that liquid is again 54, 129, and of course that's the boiling point. And what happens? It turns back into gas. It has just eliminated that block, that liquid block that happened here. Now, when you pull that vacuum, it is all that liquid that was getting in the way of that penetration that stopped it. It is now gone. Now it's turned it back into gas, and then with the pre-vac, it opens up the pump. You have cool water coming through, and the mist will attack the cool water, and it all goes down the drain. And the inside of the chamber is conditioned now to accept pure steam gas, no mist. It is just pulled whatever it is. So now you get that hard, violent push back of pressure in. Now it can drive, it jackhammers it in deeper into that load. It actually goes very, very deep. And again, it's going to produce the liquid block, in whatever it is, and it goes back down, pulls a vacuum. Any liquid block or any condensation that was built is now back into a gas, sucks it down. The mist creates a condition again to where pure heat and gas can come back in, and it dries it in. And then of course the final push. Now, if you're running waste in all the facilities that I've been in, like I said, I've been East Coast, West Coast, California, New York, Chicago, Florida, literally everywhere. I would always put in 4 pulses. The more pulses you have, the less likely you're going to get your failures. So that last push comes in, and then you can see where this ramps up. This one here goes straight up, and it'll get to the same point right here. This is where it's going to do its check. And it's going to say, okay, we're at 13 PSI. We're at 118. What's our drop rate? Drop rate is good. We're going to push to sterilization. We're going to double check, go into sterilization. And then, of course, when the sterilization's done, it's going to kick it down. Generally, as a rule, it will run into a dry phase. Some people run 1 minute, 5 minute, 10 minute. What this is doing is pulling out any mist so that when you open the door at this point, that you don't get a face full of steam or any other problems, and it goes back to atmospheric, and this is where you can open up the door. This cycle here is the champ, and this is the one that should be used always, even if you have liquids in your waste. And I know some people will run the liquids. Once I explained it to them, they won't do it. They just have to figure out how to contain that liquid when doing it. This cycle will heat up liquids way faster. Now, they will blow up. Media does go everywhere in it. If you have it contained properly, you can mitigate a lot of that. So with that, I want to show you guys some of my testing here real quick. As you can see behind me, I do have an autoclave. I have a Steris V120 autoclave. And this is something else that I always found problematic. These people that use these chemical temperature strips in lieu of a biological indicator. I'm going to show you that. I'm going to show you here. I have a beaker of warm water. I added 100 milliliters to 250 as per the recommendations from the NIH. And we're going to show you that process. These are 2 mil 12-gallon bags that I had. For the test packs here, I took a Bowie Dick, and then what I did is I just took the outer wrapper. For those of you that are Bowie Dick, it's a steam penetration test. It wouldn't work on these because I'm running to 200. I'm running the 121 cycle. So I put my biological in here. I just took and unwrapped it, and you can see that I have it kind of on a hinge. And then I fold it over. I have my chemical test strip on the inside with the BI, and then I have the chemical test strip on the outside. And what I did is I made my testing progressively hard because I wanted to show you guys the testing results to show you you're not killing things if you're not doing things the correct way. Now here I didn't tape it down. On 3 of the tests, what I did is I took a piece of tape. I had the hinge, just flipped it over. I taped it shut. I pulled it down tight to have a certain density of load, just so you know what that is. Here's my test 1. I had a hard piece of plastic, just no trash in it. I had wet bag, dry bag, chemical strip in there, and I ran it. Obviously, this was a pre-vac cycle, 3-minute purge, 4 pulse, preconditioning, 40-minute sterilization, with nothing blocking it, no trash. It truly was not that big of a deal. This bag, I did an open dry bag. I didn't even tape it. I just left it totally open. You can see my control here. This is the one I did, not autoclaved, obviously, just to make sure that my batch of biological indicators were still good. And away we go. So I ran a pre-vac, I ran a gravity, and a liquid cycle. I really didn't expect much trouble here because there really wasn't much to kind of block things. I did have my Safe-Decon BioPro 300 that I was doing with the open bag and the seal bag. With the seal bag, I taped them shut and used different methods of tying it open. But anyways, with the open bag, didn't expect much trouble out of these. I did run a liquid cycle. I only ran it once, made no sense for waste. The gravity cycle is essentially the same thing. So, but I just ran it just to run it. Here's the seal pack here. You can see where I had it hinged and then I taped it shut. That's going to be for cycles 6, 7, and 8. Here I added to the wet bag. I added some light trash to it here and 100 milliliters of water for testing coming up. Test cycle 4 and 5. These were 4. Just put a little bit of light trash, as you've seen. The trash in the bags was about 5% capacity of the bag at best. It had some just some light trash, PPE, just gloves and stuff like that. Nothing major. And then I had my plastic, my piece of plastic that I set the packs on and stuff like that. So I started to seal them. And then let's look at the results here. So the pre-vac again. This was an open dry bag on 4, not much really here, just 4 pulse conditioning, a little bit of light trash. We got through it. Look here what happened on the gravity cycle. On the wet bag, I put 100 milliliters of water in this, and the bag did not burst on this one. You can see that there's some steam indication. This is what they look like. This is your chemical strip here. This is when I started using these. And you can see that it was, it was kind of okay. The dry, and what I did with the bag here, starting on this cycle, is I sealed the dry bag, but left a hole in the top, which is what a lot of people do. They'll go, okay, we'll just put a zip tie on it, or we'll tie it and leave the hole at the top. So I left about a 1/2-inch hole in the top of this, and then and ran that. So the gravity cycle, so on the Safe-Decon was good. Sealed bag was good. This bag did bust open a little bit bigger, and we got the kill on it. And again, that was 3-minute purge, 40-minute sterilization. There was no dry on the gravity. It just closed. On cycle 6, I added the trash. And this is where you can see I added the packs. This one was just plastic on it. This was a sealed pack right here. Now, on the sealed pack, this is where I actually taped it down. I just didn't fold it over and let it go. You can see here that this bag burst and this one burst. And looky here at your chemical strips saying, hey, Bob, hey, we're good, man. We reached temperature. We had steam penetration. We had good temperature. And again, these are the popper that indicate steam and 250 degrees. We failed on a 40-minute pre-vac cycle with a tight little thing. And what I believe had happened with these two is, though this one was sealed, even with water in it, and this one had a little hole in it, they didn't burst until after, probably, my guess is probably the 3rd to 4th pulse. And they had burst open, they had broke open, the bag split, but I think it happened later during that pre-vac cycle. And because it didn't have that push and pull could access that bag, it had failed. And the Safe-Decon unit, that was a champ on this one. And the Safe-Decon unit, it was something that I engineered specifically for this problem here. And I know that, it's something that we can talk about another time. So 7, 8, and 9. Now, 7, 8, and 9, what I did is, these are the same 40-minute. I did a gravity cycle, and 7 and 8, this pack was sealed down. And again, it was just kind of tough. Now, you'll see that all 3 of them failed. And this is on the gravity cycle. And I don't want to kind of go back and explain. I want to explain a little bit, but I don't want to go backwards to explain it. But this is what I'm talking about, where you're going to get, if you're running a gravity cycle, you're going to get the liquid blocking of heat. Again, liquid is an insulator. So when you have something that's dense that you're trying to get that heat into it, it's going to have a hard time penetrating. The gravity cycle is just going to push so far. It's going to develop literally a ring of liquid around it, and it will not allow that heat to be pulled out. It's just not going to do it. And what happens is, as you can see by your chemical, it's saying, well, yeah, I did achieve temperature here, but it's not long enough to get the kill. And the reason like I said, the reason I did these chemical strips is I see this as a method by quite a few people in labs, and they're like, well, Bob, they're cheaper than a BI. And the BIs are costing me $1.20 a piece. I can get these chemical strips here, and they only cost me 2 cents. So I'm saving money. The question you have to ask yourself, especially a safety officer, hey, look at here, look at the problem. And it even failed on the Safe-Decon 300. And again, I figured it was going to fail here because part of the problem is when you have it taped down and there's a certain amount of density, it's not going to penetrate. And that's where, this thing really kind of becomes a little bit tricky. So this was the last one that I ran, and I ran another pre-vac cycle. The pack was tightly packed. Both of these bags did burst, but you see by adding water and to the bag, because the reason they wanted you to do this is because of exposure. They want you to close the bag off, add the water, and then have it go. But as you'll realize here, this is not producing steam inside the bag. If you remember your physics that I just taught you in the thermodynamics, unfortunately, that water is sitting there during the whole autoclave cycle until it gets to the end part of it, where it just opens up and then it releases that pressure. That's where you're probably getting the steam indication. And also, I'm going to go back because this is something here critical. I want to go back here real quick. I forgot to explain this to you. When you see this 54, and this is the boiling point, I want you to understand why steam doesn't kill. If this temperature and that boiling point and that steam on a vacuum, that your temperature, your steam is 54 degrees, just so you know. Here, that steam, just because it produces steam, your steam temperature is 69 degrees. So when it gets to that atmospheric and it turns to steam, it's not 212. As you pull vacuum, it gets less and less. And depending on where you are in the country, you will see that that's why steam doesn't do it. That's why you need that heat. So getting back here. So this was the last of the tight packs that I did. Ran the pre-vac cycle, the sealed water. This bag didn't bust this time. And as you can see, it showed that we had steam. More than likely what happened is eventually that water inside that bag, that 100 milliliters of water, it did heat up. And then once the cycle had completed and the pressure had dropped, more than likely that's why you're getting this false negative on these. Because when that valve opens up, by the time by the time that water finally heats up and then it releases that pressure, you're going to get that boil, but it's too late. You're already going into the pre-vac. You're only going to get a very short burst of that steam and heat, not long enough to kill your biological indicator. Now here, the sealed dry bag, it did bust open. It must have opened, during the time that enough for the contents to get the exposure. The Safe-Decon, again, champ there. We got the kill on it. So now on the packs here, I ran a a 30-minute, 40-minute sterilization. And you can see I got, now this pack here, I didn't tie down. I just flipped it. Like you seen in the very beginning, it wasn't a very tight pack. And it was a 40-minute. It was the loose pack in there. Both of these bags did bust on these during that cycle. Don't know exactly when during sterilization, but it did. And you can see that steam did permeate. This one got wet. That's why that one was this way. When the bag did burst on this one, it did flip this one into the liquids, but you can see that we got the okay. Again, chemical strips, bad BIs. Safe-Decon one here on the 40-minute, we were able to get the kill. Now 10 and 11, and here's a picture of the contents of what happened. This is the wet bag on that last one. The dry bag busted here. You can see the configuration. I took the dry bag out of this one so you could see how the wet bag did explode in the configuration. I had the Safe-Decon one in the back, and then I had the wet and the dry bag. This is a 20-inch autoclave. Again, it's a 20-inch ferrous, so I was kind of limited. And you can see how limited the amount of trash was. This bag was 5% filled with trash. Imagine more trash being in it and the difficulties in getting this kill. What I did for test 10 and 11 is I increased the amount of water, but I increased the time to 60-minute sterilization. A lot of people run 45 to 60 minutes. And on the pre-vac, both of these did bust over time. We did get your chemical strips. All three made it through. These bags, all these did bust. Where they busted, they probably busted a little early in the cycle, which allowed them to get it. 60-minute, we got the kill. Safe-Decon again. For the gravity cycle, this was a 60-minute. We did a 3-minute purge. There was no 4-pulse. It was gravity. So it was 3-minute purge. That's a little bit of a boo-boo, and there was no dry with it. So it was basically the same as you've seen. It ramped up, did 60 minutes, dropped back down, opened the door. The wet bag on this one did rupture, and we were able to get the sealed wet bag. It did okay. The dry bag stayed shut. It didn't bust. It still had the little 1/2-inch hole at the top that was in there. You can see that the indicator said that there was good steam and heat. Failed BI. Did not work. And the Safe-Decon one, we got the kill. And again, these were just on loose packs, not the hard ones. Want to get into the observations and conclusions on this. And a lot of my observations are not just based off of this test, but it's based off of the experience of going in labs throughout the whole country. One consistent observation is during the pre-vac cycle, both the wet and the dry bag, they did rupture about 90% of the time. We just don't know when they burst and at what point. And I think when they fail, it was later in the preconditioning that you did it. And if you don't get that preconditioning, you're not going to get the penetration of the heat, which is critical. And if you get that liquid or that liquid block of the heat, it's going to insulate the interior of it, and then you're going to have the problems. And I believe that it's pretty much due to the pressure differences in the preconditioning phase. And this is one of the reasons why when everywhere I went, they would have the standard three preconditioning pulses, and I increased it to 4 to give, if you don't have the Safe-Decon unit, what this does is it gives the bags a longer opportunity to try and get busted open. And to be honest with you, I know that, and I've seen this everywhere I go. There are SOPs to open the bag, or, they're supposed to do it. And what I find literally everywhere I go is people don't want to open the bag. They'll just leave that thing taped shut. I don't care where I've been. and then they overload the bags. Another problem also that I want to explain here in the conclusion, and again, this is just from experience and seeing it all over the country, is that generally as a rule, nobody follows up with anything. So you get these young kids, they're getting in a hurry and they're placing the bags. And when you press two bags against each other, you have just decreased the amount of heat that can hit that bag and go in. You have one bag insulating another. So you get two bags sandwiched together. You've taken away 50% of the area that heat can hit. You have to heat this bag up and this bag to heat the one in between it. You set something on top of it, and then that's another issue. Another problem is they'll take the bag and let's say they do open it, they'll take the bag and then they place the other one and then they press it so now the steam's not getting in. And this is where the inconsistent sterilization, decontamination of the process comes into play. And this is where the leaks, I believe, are happening. And as you can see by my testing, it's extraordinarily inconsistent. The only one that was consistent was the Safe-Decon container. And again, there's a lot of physics and behind that. And I actually invented Safe-Decon for self-preservation because of what I seen in the labs. And I am going to say something here also. And it's bothered me for years. And one of the things that happened, in fact, I just had a discussion with somebody who's very, very high up within the government. And they were like, Bob, our SOPs and this, that, and the other, it's all good. And I said, let me explain something to you. I said, as a safety officer and as a PI, I said, I know what happens, especially when you get in academia. And this is where there's a big, big problem. And I just want to get this off my chest. And especially for those that are safety officers and PIs, I get it. The one thing that nobody ever wants to do is to load the autoclave themselves. It's rare that I ever seen in almost 2 decades. I can show you on one hand how many PIs I ever seen that open up that autoclave. I can show you on one hand how many people have ever followed up. Usually when I came in and I recognize that there's a problem with the autoclave and how it's loading, then I go to the PI and I said, you can't do that. And then you need to do it this way because you're not killing what's coming out of the lab. And I don't see the follow-up. I don't see pictures on the autoclaves. And it was one of the things I kind of demanded for those that I've been a part of your lives and doing the repair work. It's not just autoclaves. I work on just about everything out there. Is just the lack of knowledge and understanding the autoclaves. The autoclave is something that's despised, it's hated, but I'm just going to be honest with you. I think it's probably one of the most important pieces of equipment in your lab. And again, I work on environmental cabinets. I understand the PPEs. I understand everything that you guys are dealing with. But let's just be frank here. Think about this for just a second and go along with me. Containment inside of a lab is very layered, and everything kind of overlaps each other. And if your environmental cabinet, if you have a malfunction on your environmental cabinet or something that happens in your environmental cabinet, you have the person's PPE that's protecting them. You have the backup of the room and the airflows and the containment of the room. If it gets there, you have the hallway, and everywhere there's airflow, and there's a lot of different things that you can do to mitigate a boo-boo. You have your PPE on top of it. You have your PAPRs, air gloves, booties. I mean, you are backed up to the hilt. And in almost 2 decades, I've never seen anybody have formal training on the autoclave for people to understand it, which is why I'm doing this today. And I hope you guys are kind of paying attention. And the reason why, and I know every piece of equipment through and through, I work on them all. The autoclave is probably the most critical, and it is the least understood. It is the least trained on piece of equipment. And the reason why I say that is once it gets in that autoclave, and everybody knows in these labs, everything except for the human being that goes in the lab and has to come out has to go through that autoclave. And yet there's no understanding. I find everywhere I go, and I'm trained people, I get after them, I force them to learn everywhere I go. You lose containment at that point. Once it goes in that autoclave, it's on the other side of the bioseal. All your airflows, everything is gone. And after seeing my testing results and knowing that I have personally been exposed and then had to go through almost 48 hours of someone telling me that I potentially could die and I may have killed my wife, it does get out. And there's a lot of problems with that. And let me tell you what some of you guys are thinking. I've heard this for, like I said, almost 2 decades. Bob, don't worry about it. It doesn't matter. Bob, it's all good because they're going to put it in the container. The wonderful people will come in a truck. They're going to pick this stuff up and then they're going to incinerate it. And I hear this story and it makes me mad because let me tell you something. I don't know if you realize this, but on average, there is 3 to 4 accidents with your waste on the highway every year. They scrub it off the internet, but if you'd like to see videos, I have them. I have people around the country that have sent me pictures and videos. I have one where a red bag truck had an accident, and it was literally downtown Tampa. And the containers had split open. The truck driver got out. He's trying to clear the way for traffic to go around. And he's picking up the waste. He has gloves on. He doesn't even have an N95 mask. He doesn't even have a doctor's mask, which are worthless. And he's trying to pick up your waste from, and this is from a lab. I don't know which one it was from, but the truck was full. And then I have a video of a mom going by with a newborn baby in a stroller, literally walking through it, and people stopping to help pick the containers up and picking this waste up. So when you say that, Bob, don't worry about it, I worry about that. It is our responsibility. It was mine, and I took this job very seriously because when I seen that things were getting out, I educated literally everybody, and I made sure that people, if they didn't follow my rules, then I would get mad and I would actually get after them about it. But we know how it works with this. It is important. It is imperative that in these labs that we know for sure that that stuff is getting out, because once it's out of our hands, we're relying on a truck driver to safely get it there. I can tell you that when it does get to the red bag companies, they're wearing pappers because they know. They're all wearing Tyvek suit, pappers, and everything because they know that you're not killing it. We all know that you're not. And sorry, got on my little stool there, but I need, for the sake of time, I need to keep going. But anyways, the concern of adding water to it is a problem. You know, as you can tell, it really didn't help it much. I'm going to breeze through this. The pre-vac cycle, the dry bags were 33% effective. Wet bags were 66% effective on the pre-vac. The Safe-Decon container was 100% effective. Gravity cycle, the wet bags were more effective than the dry bags. It's supposed to be dry bags. The wet bags were 33% effective. The dry bags were 0% effective for the dry bag. Seal container, and it failed on that one, and that was on there. Obviously, we should go with the pre-vac cycle for sure. I'm going to blast through this. It should be noted that when the bags did rupture, the waste was scattered inside, and as you can see, it may not have been decontaminated. Somebody has to handle that. Also, one of the big things I see in labs and even in mine is when there was liquids in the bag, when they burst open, you go to remove the bag. It may not be decontaminated. You spill it on it, and plus with the hot water. I think the practice of adding the water to the waste bags, that should be ended immediately. Pre-vac cycle should be the primary waste cycles used, even for autoclaving liquids. a container should be used to contain those little spills and leaks. It is going to be the most effective and efficient way of doing it. And I get it. You can't use those when you're, sterilizing your water, but for waste, it's a whole different thing. Gravity cycles should be used sparingly. If you do, I recommend that you run at least an hour and a half, 90 minutes minimum. And depending upon the load, and this is what you guys need to realize, the more load you have and the more you add to it, the more challenging it becomes. As you can see, I only added 5 to 10% of waste to the bags, and you see the failures with, imagine if they're full, what that's going to do. Liquid cycles should never be used for waste cycles at all, unless you can use the load probe to be able to control the temperature. And with that, yeah, I apologize. Went a little bit long. I got on my stool there and did a little bit of preaching. I apologize, but safety and getting it done right is an absolute passion for me, as you can tell. It does aggravate me, but especially exposed, it was very personal for me. And so with that, if anybody has questions or anything that you need, please feel free to ask me. I can explain it to the best of my ability.
Yes, yes. So thank you, Bob. And yes, as everyone can see and surmise, there's definitely a lot of passion. Certainly there's education that's involved. Everybody, just doesn't understand. We're having conversations, and people, think we're, door-to-door salesmen. And this is a little bit more than that for us. This is something that is going to be completely revolutionize the industry, and we're going to actually have a standard in the industry. So let's have a question, or let's talk about the questions. We do have some questions. If you do have any questions, please drop them in the chat. Let's take a look at the questions. We did have some questions. One was about we had a question when people first signed up. I see one was about red bio bags that are placed over carts for decontamination. What about the red bio bags that are placed over case carts for decontamination, Bob?
A lot of them, I'm a little surprised by that. And I know this is just in operating rooms. The operating rooms, they usually have a dedicated cleaning crew that comes in. It takes the trash, but I guess what it is, an SPS on them. They must have people doing that. Hopefully they have the proper PPE gloves and everything else. Yeah. So again, Garth, I appreciate it. I see your, one of the problems is I have a lot of information. I have about 2 and 3 hours worth of information, and I tried to cram it into an hour. So I do want to apologize. I had to speak like a New Yorker, unfortunately, to get it all in, but I did. So, yeah.
All right. Okay. So we did have a question came in, and I think I'm Joshua. I hope I'm saying Joshua. I hope I'm saying.
Yeah. Thank you. It's Jayshree. Yeah, thank you.
Jayshree.
Thank you for attending. Thanks for being here. We appreciate everybody who is interested in this conversation. And there was a question about which cycle is best for waste. Is it the pre-vac? I basically said you give some details on that and Q&A.
Yeah, you definitely want the pre-vac because one, if there is a bag that is closed, the pre-vac cycle has an opportunity to bust it open. And again, everywhere I go, they're supposed to open the bags, but part of the problem with opening up the bags is you create a potential aerosol effect that when the bag opens, that it collapses and whatever air comes out can actually get. So a lot of people really don't want to fool with that. One of the reasons why I like the pre-vac, and I always, when I'm the technician, I always put the four preconditions to give it more of an opportunity to expand that bag and contract it to get it to blow open and expose the contents to that steam and heat. And again, people have a misunderstanding about steam and its purpose. Steam is not what kills, it's the heat. but the steam is what pulls that heat in. Steam is attracted to cool. It's going to pull that heat in, but the minute it condensates, you're going to get that block. And that's why you get more failures out of the gravity in the liquid than you do a pre-vac. If you look at the data and the information that I have, the pre-vac was way more effective. But then again, that just depends on when does the bag open during that pre-vac cycle. If it opens, during the third or fourth phase of the preconditioning, you're not going to get that steam and heat penetration to the contents, and then you're going to get the failures, as you can very well see.
So can I have some follow-up question on this? When you're
Sure.
saying open, that means the bag really opens completely from the top, and then
That's correct.
when the cycle is done, do we see an opened bag with an exposed contents in it? Is that?
That's correct. Yeah, and as you can see by the testing, if the bag is and these bags, especially the dry bag, because a lot of people, what they do is they'll put a tie wrap, or they'll put a hole in there, about ½ inch like this, and then you kind of restrict it a little bit. But if that bag folds over in any way, it will hinder that heat and steam penetration. Now the bag's going to blow up, and then it's going to retract itself. When it does, everything shifts and that bag can fold over. The minute it folds over and it doesn't expand, and you pull the vacuum with the moisture content, it can actually reseal that bag shut, so that when it goes to pull the vacuum, it's not going to pull everything out. And again, during the results, you can see the amount of failures that I was getting. Be honest with you, it failed more than I thought it was going to. It actually kind of shocked me a little bit, but the physics and the thermodynamics of how an autoclave works and why it actually starts making more sense. And this is why, again, this is why I'm trying to help people to overcome this, because they're not killing everything that's coming out of this labs. Your labs are, from my best guess in 2 decades, I always thought it was a 50-50 chance that they were getting through it, after seeing how everything was loaded and processed and everything else. At best, it's 50-50.
Oh, thank you. So then you're saying that to the end of the cycle, we get a collapsed closed bag because of the cycle.
It'll close, yeah. As it expands, then at the end of the cycle, it's going to look like a crumbled, wrinkled mess.
Yeah.
And that's why I showed you in that one picture. I wanted everybody to see that, like the one bag, it just remained the sealed wet bag. It just blew up like a balloon, and it didn't burst. That cycle did fail, even though it did have the water. It did show that it got the steam and the heat according to the chemical strips. But the biological, which is the ultimate way to test whether you have gotten the kill on something, is that biological. You can kill that. If you can kill that spore, that bacillospore in that biological, you're going to kill just about everything else. But yes, and that's why the pre-vac cycle, even if you have liquids, it actually causes the liquids to heat up quicker and to get done. The pre-vac cycle is the champ of waste cycles, no doubt about it.
Okay, that makes sense. It's so hard to take out those BIs from those bags.
It is, and that's what that's what everybody hated. And again, that's one of the reasons why I invented the Safe-Decon product. It actually just simplifies that whole process. You can stack them on top of each other. Yeah, I got tired of the exposure. I've actually had more than 3 exposures. I worked in 2 facilities that it did influenza every year. That was their thing. And every year I would go down to do either PMs or do a repair. On the clean side, within 24 hours, I had influenza. I never had to take a flu shot, because whatever it was that year, I ended up with influenza. So I know it was getting out, and I kept getting after everybody as much as possible. But some people, unfortunately, they don't get it. And they were like, Bob, that's, yeah, for 10 years that I went in this facility, every year I went in, I got influenza within 24 hours. Go figure. Oh yeah, you're killing it all right, Bob. There's nothing to worry about. No, there was a lot to worry about. And early in my career, like I said, that's where a lot of my exposures happened. I got a lot smarter as I went along, knew who I was dealing with, what they were dealing with, and tried to overcome it. But like I said, with the Safe-Decon unit, I have a BI load pro port that our units are actually airtight and impermeable. You can't overload them. They're stackable. A bag has to get the heat from the outside into the contents. Safe-Decon is an inside out. I have a BI load pro port that I invented, so you can inject the BI, you can pull the BI out. It's as simple as just plugging plugging your phone into the wall, and then the BI comes out. You just run your BI. Everything remains airtight. You run your BI, and it just makes it simple, easier. And we have a lot of people that are using it, but it also decreases the autoclave time as well. I'm just doing, not a shameless plug, but this is something that's for safety's sake. We have people from Texas Tech to Yale, Tufts, University of Florida, a lot of BSL-3, University of Iowa, Stanford has a unit that they tested. Also, I have a white paper. I figured out the thermodynamics of, just real quick, of murine carcasses and why they take so long to run. University of Florida, they run a lot of mice. I was able to reduce their autoclaving time for their murine carcasses from 4.5 hours down to a 48-minute cycle. They are now getting a more predictable 100% kill rate on 48. When they were running at 44 hours, 4.5 hours, almost 5 hours, their kill rate was at 60%, even at that. And so the thermodynamics of all this, Safe-Decon just uses the thermodynamics of the autoclave to enhance it and work much better. But if you're going to get bags, contain them. Yeah.
Okay, thank you so much. Yeah.
Mm-hmm.
Will we get the contents of this presentation?
Sure. Yeah, there should be a link. It'll be on YouTube. There's a lot of people that did this, and I did something similar up in for ABSA up in Cincinnati, Pat.
Yeah, yeah, you got one, and I was, and I have to just come clean. I'm hearing everybody say it. I'm looking here, and it did not record. I thought it was something that I had already set up.
I had it recorded, Pat. This will be, yeah, I had it recorded, and everyone will be able to see it online.
Okay, thank you, Jay, coming through in the clutch. That's dream work. So I was just gonna come clean. All right, my brother Jay has saved the day for me. All right, you got a bottle on me, sir. So we'll get it chopped up. We did have one in Cincinnati, in Mayberry that we did. That one is online. We're going to talk on this one. It's going to be everywhere. It's going to be on the social media platforms. Everybody that attended, we're going to send you guys follow-up information. Definitely appreciate you guys coming. And of course, we're going to be at ABSA. We know a lot of universities, a lot of organizations aren't going to be at ABSA because of the government shutdown and budget and a lot of that stuff. But we're going to be at ABSA. There's going to be a podcast at the end of next week, Friday. Sean Kaufman, Safer Behavior.
Correct.
Pretty. Is it going to be? Is it going to be this? Amped up Sean Kaufman style. Okay. So that'll be next week. Certainly. You can tune into that. You can go to the website.
And yeah, if you can email if you have other questions afterwards. Please.
We can
The one thing, I'm about safety and making sure that people don't have to go through what I did, and I would be more than happy to answer any questions that you may have. And I guarantee you're going to leave here and you go, "Wow, I should have asked this." Go to the website; it has my email address. Please don't hesitate to email me. I have shown up at facilities to help people out as much as possible. We do demonstrations for our product, and then I go through procedures and everything else to help people out. And this is just what it is. This is about making everybody safe and making sure. So please
Yeah.
don't hesitate to reach out.
Yes, and please, know that when you go back amongst your peers and you're having these conversations, you're gonna meet some apathy. You're gonna meet some folks that don't understand. If you got any questions, even if you're running into some coworkers that you're having this real discussion and they're telling you the same thing that they told Bob and a lot of folks in the industry not to worry about it, please give us a call. We don't mind having discussions, sending out emails. We're talking to health department aficionados. We're having real conversations. And Bob's actually going to be doing a lecture November 18th at The Ohio State, giving some information. You're doing the same thing. So this is something that is huge that people think that they're doing decontaminating stuff, and they're putting the staff in danger and they're putting the public in danger. So anything we can do to help on that, we would love to. Okay. Definitely want to respect everybody's time. Any other questions? Anybody else got anything else? We're here for you. Go ahead, fire away.
I think that's it.
All right. I wanted to make sure we had an uncomfortable silence, and then we're good to go. All right.
Yeah.
Thank you, everybody. We appreciate you. We'll send out until next time. Everybody take care.
Bye-bye. Thank you.